We present CloudDet, an interactive system for visually detecting and analyzing anomalous performances in large-scale cloud computing systems. Our system integrates an automatic anomaly detection algorithm and a set of visualization and interaction designs. The system consists of 4 major modules: a data collection module for the performance data collection of the cloud computing system, a data preprocessing module for the matrix extraction and alignment, analysis module for temporal pattern matching and anomaly detection, and finally a visualization and interaction module for the interactive anomaly analysis. In this video, we demonstrate the application of CloudDet by analyzing a real-world data center traces from BitBrains. The dataset contains 10 performance metrics of 1,270 VMs over 1 month. Start with a spatial overview. The expert observes the overall anomaly degree of different data centers and clusters and selects a specific one by clicking or inputting the ID. Then the temporal overview appears to show the time-varying anomaly scores of the selected cluster in terms of performance metrics. Here the expert uses the stacked bar chart and does not filter any metrics. In hourly granularity, a period from August 7th to August 15th is brushed due to its high anomaly scores. The selected segments of computed nodes are ranked in the rank view based on their outlier degree within this period, and their corresponding performance metrics are visualized in the performance view. Each part in the rank view represents one compute node. The expert can compare the anomaly score among different metrics from the bar chart or flip it to obtain text information. The calendar view shows a potential periodical pattern of a node, with each cell representing one timestamp and the color encoding the anomaly score. After tuning the slider bar to change the arrangement of the calendar, the expert finds one node that shows a periodic pattern of 12 hours at the most time. Then he continues analyzing the node in the performance view, where the horizon chart for its matrix verifies the periodic pattern. Here, the red or blue color determines whether the metric value is higher or lower than the average. A darker color shows a larger deviation. This node is abnormal due to the irregular spike occurs in the middle. When he brushes the spike area and claps it into a glyph, he finds the metrics turn to the periodic patterns as before. The glyph for each metric is designed for data abstraction. The colors of the top, middle, and bottom rectangles encode the maximal, average, and minimal value of the corresponding metric in the collapse area respectively. Moreover, the filling color is blurred to express uncertainty of the abstraction. Let's get back to the demo. By comparing the glyphs for 5 metrics, the expert could tell that the CPU is the most unstable in this period. The expert continued his inspection according to the ranking and finds some other anomalous performances like the mix of short and long-term spikes and the inconsistency between metrics changes. The expert also tries other modes and directions in this view for anomaly inspection. After exploration in a temporal context, the expert switches to the cluster view. He quickly identifies 3 clusters of nodes. To compare the 3 clusters, he clicks the dominant dots in each group, and another glyph appears to facilitate the understanding of their performance. In particular, the glyph contains 5 arcs which are equally divided around the inner circle. Each arc illustrates one performance metric. The radius encodes the average value of its represented metric. Moreover, a circular timeline is used for each arc such that the detailed metric value changes can be plotted within the arc. For example, compared with other nodes, the nodes in the bottom right cluster have a large red arc whose color is not distributed consistently, which means a large unstable CPU usage. He can click the node to retrieve the original data of the node. We have presented CloudDet, a novel interactive visual system for exploring large-scale cloud computing data and analyzing anomalous performances.